Okay, for the first, we look at the first example of the program loops. We are using the simple branch, which use the CCR as a condition. Okay, so look at here, we have this program loads 8-bit data, that is AE. So we are trying to load the data, and the data is AE into 100 locations of memory. So we want to load the data into the memory, which consists the same data with amount 100 locations. Okay, and the starting of address is 850. So what we have to do is we have to develop the flowchart first. Okay, so we start, and then we have the data we put into accumulator A. So after execute, A will have AE, and then we will use a B as a counter, but I'm sorry, we have correction here. B is not 100, B must be 99, because the memory locations, we have 100 memory locations, but the counter must be start with 99 because the last one is 0. So 99 until 0 is 100. Okay, so B is 99. So 99 is in decimal number, and we put X as our first address. First address is 850. So X, we have 16 bits, so we put 4 digits of hexadecimal number 0850. And then next, what we have to do is A must be load. What we have in A is AE. We have to load into memory. So what is our memory is pointed by X. So what we have in X, we have 850. So now AE is insert into 850 in memory. That is the first instructions. And then next, we will increase X by 1. So before is 850, so now it become 851X. Okay, and then the same operation, A insert into memory pointed by X. So A, we have AE, and then we will insert into the new X. So now our address memory is 851. So A, we have AE. So the second data is insert into the memory, the second memory. And then we have to increase B by 1, our counter. So our counter is 99, now our counter is 98. And then next, what we have to do is the condition, B equal to 0. So now we know our counter is not 0. So what happen if not 0? So it will go to this. So this is a looping. So we will always repeat this as long as B is not equal to 0. Okay, so we have to increase X plus 1 become 0852. And then 852, we have the data AE now. And then B is 97. And then we test again, B equal to 0, no. And it will always repeat this until B equal to 0. So what happened after B equal to 0? So the mission is complete. So mission is complete, so we just end our program. Okay, so from start until here, we already learned before. Okay, we just easily convert the flow chart with the instructions. and what we have to do is we have to know which one we have to use for the condition, which instruction for branch we have to use for b equal to 0. We have to refer to the CCR. Either C is suitable, or either H is suitable, or Z, or N, or V. Which one you think that this must be replaced with the instructions? Okay, so first what you have to do, you have to change the flowchart first. Okay, we cannot let the branch instruction to be loop the program with no. Okay, we have to change to yes. The flowchart must be changed to yes to make it loop. So you have to redraw your flowchart. So you have to put b must be not equal to 0, and then go to yes, right? When b, our counter has a value, so it will loop, it will repeat the instruction again, these instructions. And then what happened to it when equal no, so it will end the program. Remember, if you have the flowchart or you design the flowchart, make sure the branch instruction you have to change with yes. Okay, not no, because we will choose the suitable branch instruction based on yes. It must be yes. Okay. Okay, how do you convert this instruction? So start, normally we use origin. So I prefer to use origin 800. Why 800? Because until this subtopic we are using the simulation. So the simulation use 800 for write the program. So our instruction is starting with 800. So just convert origin to 800, and then you have the data AE. You want to insert into accumulator A. So remember back what you have learned in subtopic data transfer. So we have instruction, we have the data to insert to the accumulator or to the register. You have to use load. Okay, so these three instructions you have to use load. Load A, and then you have to use the immediate mode because we have our own data. AE, okay, LDAA, hashtag AE, 8E, and then load AB, hashtag 100. Okay, and then load X, LDX, $850. Okay. Now we have these three instructions. Okay, and then next, so we have from register we want to copy into memory. Just now we want to copy the data into register, so we have to use load. And then now we want to copy from register to the memory, so you have to use instruction store. So store from AA, STAA. Now we are using the memory pointer. So memory pointer, our memory pointer is X. So we have to use index addressing mode 0,x. So when 0,x, we use 0,x mean X plus 0. So same, this one X, still same. X plus 0, same with X. And then we have to use the label here because we will make it looping. Okay. So this one is increase X by 1, use I and X. So this instruction repeat, so just copy. And then this one is decrease B. Decrease B. And how do you want to choose the appropriate or the suitable branch instruction? When the instruction need to compare value and no value, so you have to use zero flag. Okay, remember back when z equals to 1, it means yes, there is 0, means the operation 0. Okay, this is when b equal to 0, and then for z equal to 0, no, we have the data, so when b is not equal to 0. Okay, so what we have to use is either z equal to 1 or z equal to 0. And now we have the condition yes is when b is not equal to 0. So when b is not equal to 0, so we have to use z equal to 0. So look at back our table. Okay, when z equal to 0, so we have to use b and e. So our instruction is b and e, branch not equal. Okay, now we have a branch not equal loop. So when the condition is true, so it will go to the loop. That's why I told you, you have to change your flowchart to be looping, use yes. Because the condition here is if b not equal to 0, go to loop. Okay, so it will go to the loop here. Okay, so make sure this one for looping we have to use yes, not no, not this one, not this one. You have to modify the flowchart. Okay, and then we have another branch that is a primitive loop, and it simplify the instruction. Okay, we have two instructions here, decrease b and branch not equal loop. We can make it only one instruction. Okay, decrease b, and then we have branch not equal loop. So we can make it as one instruction only. Okay, using the primitive loop. So we choose d because decrease. D is decrease, b and e same, branch not equal, and then we have b is our counter, decrease b, and this is our relative mode. Okay, okay, we have another loop primitive. It is not only db and e, so we also have dbeq. Okay, decrease, okay, branch equal, and then we have to put counter and the relative mode. And we have also increase branch equal and increase branch not equal.